In today's lesson, we're going to take a look at converting improper fractions to mixed numbers. And we're going to do this in two different ways, the traditional method and the pictorial method. We'll look at four different problems, and here are the directions. Convert the following improper fractions to mixed numbers. Use traditional and pictorial methods. Problem number 1, 27 fifths. Number 2 is 49 eighths. Number 3, 57 sevenths. Number 4, 41 thirds. Now, if you're trying these at home and you want to pause the video and copy these down, please feel free to go ahead and do that. So let's move on. We have this improper fraction. You can tell that it's improper because the numerator, 27, is larger than the denominator, 5. So, how do we do this? Well, we have to make it equal to a mixed number. And a mixed number, we've talked about this in previous posts, is a mixed number is a number that has a whole number portion and a fractional portion. So, how are we going to go from 27 fifths into a mixed number? Well, the first step is to divide the numerator by the denominator. And really, that makes sense because every fraction is also a division problem. You can look at it and read it this way, 27 divided by 5. So let's go ahead and do that. We got 27 divided by 5. I'm going to move this down so we have a little bit more workspace. Okay, there we go. So you might be thinking to yourself, 5 goes into 2. Well, nope, it really doesn't go into 2. That's true. So, I mean, we could go through the steps and say, well, 5 goes into 2 0 times. 0 times 5 is 0. Subtract, and you get 2 once again. However, you bring down the 7. We have 27. If you're a little rusty on division, you can check out our division posts. Feel free to do that. Well, let's move on. 5 goes into 27 how many times? Well, I'm thinking to myself, 5 times 5 is 25, but 5 times 6 is 30, so that would be too much. So we'll go with 5, and 5 times 5 is 25. Subtract, 7 take away 5 equals 2, and 2 take away 2 equals 0. So we're left with this 2 down here. And what do we do with this 2? Well, automatically I can tell you that the whole number part of your mixed number is this 5, okay? Because 5 goes in to 27 5 complete times. So 5 times 5 is 25. But as you can see, we had a remainder of 2. Well, when you're making a mixed number, you take that remainder and you put it over the divisor. And the divisor is this number here. Okay, you're dividing by 5 here. So we'll put 5 as our denominator, and that should make sense to you because we started off with 5 as our denominator up here. You're dividing by 5. So you take the remainder, 2, and put it above as your numerator. So what you have here is a whole number 5 and 2/5 of another. Does that not make sense? Well, maybe. It makes sense mathematically, but if you were to look at it pictorially, sometimes it really brings more meaning when you look at something using the pictorial method. So that's what we're going to do. We've got the original mixed number over here, 27 fifths, and we need to show that in picture or pictorial form. So what I'm going to do is, I noticed that denominator 5. Been talking about that a lot. Well, the denominator, if you remember from our previous posts about fractions, the denominator tells you how many parts or equal parts make up a whole. So let's do that. We've got, well, I'll make a whole, and it needs to be divided into 5 equal parts according to our denominator. That's the denominator's job. That's what information it gives you. So you can clearly see that there were 5 equal parts there. How many fifths? Well, there's one, write that down, 1, 2, 3, 4, 5 fifths. make up that whole. However, we need 27/5. Okay, well that's one whole, that's great. But 27/5, how many whole pies would that be? Well, here's another. And remember, they all need to be divided according to that denominator over there. And again, it's 5. Our denominator is 5, so we'll divide our pie into 5 equal parts. And now, you can see that we would have, all right, there's 6, 7, 8, 9, 10, and then we have to get to 27. Well, if 2 pies equals 10/5, then 4 pies should equal 20/5. So let's check that out. We've got 11, 12/5, 13/5, 14, 15/5, 16, 17, 17/5, 18/5, 19, and sure enough, we have 20/5. So you can see 4 whole pies will give you 20/5. And we need to get to 27. Okay, let's see how many more we need. I'll keep drawing these pies until I have 27/5. I will continue this. You're probably thinking, well, this pie will give you 5 more pieces, giving you 25. Well, you'd be right. Good for you if you're thinking ahead like that. It's true. So 21, 22/5, 23, 24/5, 25, and we still haven't hit that number. And what number am I talking about? Well, the numerator, you know, because this tells you how many of those parts we have. We have 27/5, and so far we've only found 25, so we need to draw another pie. I mean, again, fractions could represent really anything, so we just chose pies. They're kind of easy to work with and easy to understand, and pies are easy to enjoy, by the way. But anyways, so there's 5 more fifths to make up that pie, and we'll keep counting. So we were left off at 25 over here. Now we'll do 26 and 27. Ding, ding, there you go, bingo, we got 27/5. So you think to yourself, okay, if I'm making a mixed number, I need to look at whole and fractional parts. So how many whole pies do I have? Look at that. 1, 2, 3, 4, 5. I have 5 whole pies, and our original answer over here was 5 2/3, remember? So that makes sense. There's 5 whole pies, and, well, we should have 2/5 of another. 2/5 of another. Do we have that? Well, look at that. It sure looks like we do. There's another 5th and another 5th. So we're looking at 2 out of 5 slices of this pie are there. So that's where we get that 2/5 from. And we end up with the same answer. And there you go. 5 2/5 is your answer. Let's move on to the next one. 49/8. Again, like I said before, you could treat every fraction as a division problem. So we'll set that up. We've got 49 divided by 8. We read it top to bottom. 49 divided by 8. Okay, now we're thinking 8 goes into 4. Well, no. Really, 8 doesn't fit into 4. So, I mean, you could skip over and include both digits there. So we have 8 goes into 49. Okay, I can do that. 8 goes into, let's see, 8 times 5 is 40. 8 times 6 is 48. Well, that's pretty close. 8 times 6 is 48. 8 times 7 would be 56. That'd be too much. So 8 goes into 49 6 times. 8 times 6 is 48. Subtract, 9 minus 8, you get 1. 4 minus 4 is 0. So again, you have a remainder. And when you're dealing with mixed numbers and improper fractions, and you're dividing here, you've got this divisor, which becomes your denominator. Like the original improper fraction, the denominator, what you're dividing by over there, was 8. And that continues to be the same. So now we have 1 left over, according to our remainder, and we'll take that 1, This is the one I'm referring to down here in your remainder. And we put it up top of the 8. So you're left with 6 and 1/8. So really, wow, look at that. So really, you've got that original problem, 49 divided by 8. And if you work it out, it becomes, you get the answer 6 and 1/8. So we've kind of proved that 49/8 equals 6 and 1/8. Now, if you're doing the pictorial method, you take 49/8. Just going to rewrite that so we can see it right here. 49/8, and I need 2. Divide this whole into 8 equal parts. Hey, maybe it's a rectangular pizza. How about that? Okay, so we've got this whole pizza divided into 8 equal parts. And technically, like, these should be equal parts of equal size. But with math drawings, you really are representing your ideas. So let's continue. So we can all see that that would be 8/8, right? And we continue adding 8/8 until we got to 49. So there's 8, and I'm going to do a little trick I can do here. Let's see. I'm going to clone this. So we've got 8, 16, 8 times 3 is 24. Save us a step here. That's okay. So far you've got 8 out of 8, so it's 8 times 3 is 24/8. 8 times 4 is 32/8. We're trying to get to 49. 8 times 5 is 40. 8 times 6 is 48/8. And we probably need one more. Okay, remember, because we got 49/8, and 8 times 6 is 48 slices, but we need to get to 49. So let's count these out. All right, let's just check them off as we go. All right, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 eighths. You could have done 8 times 2 is 16. That's fine. You keep doing this, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. You can just count along with me, 41, 42, 43, 44, 45, 46, 47, 48 eighths, and we need 49. And there's just one out of this last pie or pizza or whatever you decide to draw. And then you would have 49/8. Now, to make that a mixed number, like I said, each one of these full pizzas is 8/8. Okay? So we got 1, 2, 3, 4, 5, 6 whole pies. So that equals 6 whole pies. And then if you look at this pie right here, you've got 1 slice out of a possible 8 slices that make up that whole pie. So that would be your fractional part of the number. So it's 6 and 1/8 would be your answer. Now you should check that out with your original calculation, 6 and 1/8, and there you go. They do match, 6 and 1/8. Let's try the next one. 57/7. All right, so we've got 57 divided by 7. We can do that. We're going to set that equal, and we'll have a mixed number. All right, so 57 divided by 7. 7 goes into 5. Well, no, it goes into 0 times, really. So 0 times 7 is 0. Subtract. 5 take away 0 is 5. Bring down the 7. We have 57. Well, I know 7 times 8 equals 56. You're probably thinking that too. Good for you. So that's as close as you can get to 57 without going over, because 7 times 9 would be 63. That's too much. So 8 times 7 is 56. You subtract, 7 take away 6 is 1, 5 take away 5 is 0. Again, you've got this remainder of 1. Now you got to think to yourself, what would my denominator be? Well, the denominator really remains the same from your improper fraction, and it's also this divisor here. So you'll put your remainder 1 over 7. So you've got 8 and 1/7 as your mixed number, 8 and 1/7. Now to draw the pictures for this, it might be a little tricky to draw sevenths. So let's give it a try. All right, so we've got, there's a 1, 3 on that side, 3 on this side. So 1, 2, 3, 4, 5, 6, 7. All right, yep, we've got sevenths. Yep. All right. So that would represent, and you can see each of these dots represents one of the pieces of the pie, or pizza, or candy bar, whatever you're dividing up. So we need 57 sevenths. Again, I'm going to use that cloning the picture trick. So let's see. All right, so, and you know, we're proving what we showed up above. We've got 8 and 1/7, so we're expecting to have 8 full pies, or candy bars, or bologna sandwiches, or whatever you decide. Oops, I missed part of it. Let's see. Try again. Oh yeah, we're missing part of it. That's okay. We can draw that in. Okay, so there's 1, 2, or like I said, up in the numerator up here, you need 8 whole. That's why it's easier to do your calculation first sometimes, and then prove it with your pictorial answer. There we go. All right, so 8, 16, 8 times 2 is 16, 8 times 3 is 24, 8 times, whoa, back up. We're working with 7. 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, and 7 times 4 is 28. We're trying to get to 57. All right. 7 times 5 is 35, 7 times 6 is 42, 7 times 7 is 49, 7 times 8 is 56. So we've got 56, and like that mixed number we found earlier, 8 and 1/7, we'll need another one to show that 1/7. So let's bring that down. If you're doing this at home and you're kind of trying to copy it, you might want to pause the video. I know I'm moving a little bit quickly here. And this time, instead of counting each and every single one, let's work on multiples of 7. We've got 7 sevenths, so let's 7, 14, 21, 7 times 3 is 21, 28, 35, 7 times 6 is 42. If you lose track, you might want to just jot yourself a little note. There's 42 sevenths so far. Okay. 7 times 7 is 49. 7 times 8 is 56 sevenths. And then we have to get to 57 sevenths. So we'll take a look at that last candy bar down here. And we'll shade in this part. Must be a blueberry candy bar. Okay. So we've got 1/7 there. So that's the 1/7 part. And we circled 8 whole ones above. So again, you get 57 sevenths equals 8 and 1/7, just like we proved up there. So your answer, once again, will be the same for both. 8 and 1/7. And the very last one we're going to work on is 41 thirds. And you approach that same way. We've got 41 divided by 3. 3 goes into 4 once. 1 times 3 is 3. Subtract. 4 minus 3 equals 1. You bring down the 1 in the 1's place there. And you get 11. So 3 goes into 11 how many times? 3 times 4 is 12. That's too much. 3 times 3. Yep. 3 times 3 is 9. Subtract. You get 2. What do you do with that 2? Well, you keep the same denominator. We use that divisor up here. So it'll be 3. And let's see, your remainder down here was 2, so we'll put that up above. So we've got 13 and 2/3 is your improper fraction. So let's set it equal to 13 and 2/3. I think for this one, 41/3. Might take us a while to draw this picture, so let's go back to our pies. 41/3. We have to represent that with pictures. Make blueberry pies this time. We can expect, to draw 13 whole pies and 2/3 of another. So here we go. All right, we've got 8. 12 pies, 13, and then an extra one to show that fractional part. So, all right, we've got thirds, and we could divide that into. Again, these math drawings don't have to be perfectly accurate because you're just representing and proving your ideas. It's always good to show proof when you're working in math. Prove you know what you're talking about and know what you're thinking is correct. Okay, so now we've got 41/3 for each of these. There'd be 3, 6, 6/3 with 2 pies, 9/3, 12/3, 15/3, 18, 21/3, 24, 27, 29, 30. 10 pies would be 30/3. That makes sense. If you want to, like I said, if you lose track, just like jot something down. Okay, there's 30/3. I'm working on 33, 36, 39, and then I should expect to have 2/3 of this one, and I do. So I left off, it was 30, 33, 36, 39, 40, 41/3, and there we have it. So that's our 2 out of 3 one, 2/3, and we actually filled in 13 whole pies there. You could count them up if you need to, pause and count if you need to. But you end up with this same mixed number. 13 and 2/3. And there you have it. Thanks for checking out Mr. Marinick's EduBlog, and we'll see you again next time.